Hi, in today's lesson we're going to talk about the power rule, which is another one of the exponent rules. So let's go right in. So we'll see the first problem has already been done for us. Now, the power rule is when you have an exponential expression that is also carried to an additional power. Some of the people might refer to this as the power to a power rule. Okay, that is a correct way to say this as well. So the very first one, we have the expression, the quantity 2 squared cubed. And notice we have the heading first repeated multiplication and second repeated multiplication. So let's look at the first. So when I have 2 squared cubed, that means we have 3 groups of 2 squared. 1, 2, 3. Okay? Now that we've expanded out that outer exponent, now we're going to expand the 2 squares. So, here's a group of 2 squared, here's a group, and here's a group. So they're all expanded out. Altogether, that's 6 2's being multiplied together. So it's 2 to the 6th power. Let's try another example. This time we have 5 cubed to the 4th power. So when we expand, we do the first repeated multiplication, we're going to do 4 groups of 5 cubed. So there's 1 group, 2, 3, and 4. Now when I expand it out a second time, so 5 cubed means 5 times 5 times 5. So what I'll do is I'll underline this one so you can see. Actually, you know what? Give me just a second. Let me change my colors here. And that way we can do it a little bit easier. And I'll get one more color. Okay. So the first group of 5 cubed. So 5 times 5 times 5. And then I need another group of 5 cubed. 1, 2, 3. And then I need another group. 1, 2, 3. And then I need one more group. Okay? So how many 5's do I have being multiplied together? 12. So this is going to be equivalent to 5 to the 12th power. That's it. Okay, you'll notice the next one is asking you to work backwards. So you have 7 to the 12th power. So one way we can do this is we can work completely backwards. So the second repeated multiplication would have been 12 sevens being multiplied together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there are 7 12s being multiplied together. If I want to group it like you see the other two, there are several ways that I could go about this. So I could say here's a group, here's a group, here's a group. I could do groups of 2. Okay, so that's one thing that I could do. And if I do groups of 2, each group of 2 is 7 squared, right? So 1, 2, and I have 6 groups. 3, 4, 5, 6. And so what would that look like in the beginning? So that 7 squared would be in parentheses, and it'd be to the 6th power. So 7 squared to the 6th. That's one answer. There's more than one way that we could have done the 7 to the 12th. Okay, let's look at the next one. So this time they gave us the first set of repeated multiplication. So we have x to the 6th times x to the 6th times x to the 6th times x to the 6th. So we have 4 groups of x to the 6th. So that x to the 6th is in parentheses. And then outside of the parentheses, it would be to the 4th power. Okay, so again, if I expand this out a second time, and I don't know that we're going to do that for this one, because if I do, I'm going to write 6 x's, and then another 6 x's, and then another 6 x's, and then another 6 x's. So how many x's am I going to end up having here? You're right, 24 x's, if you said 24 x's. So this is going to end up being x to the 24th. I'm going to put a line there. And if you'll put a line there too. Okay. So I'm hoping that you're noticing what's going on here with these exponents. But let's try out this last one and see if we're understanding. Okay. So I have 3 to the 5th y squared, that quantity, cubed. So that means 3 groups of that. So here's my first group of 3 to the 5th y squared times another group of 3 to the 5th y squared times my final group of 3 to the 5th y squared. So if I expand this out, that 3 to the 5th y squared means I'm going to have 5 3's and 2 y's. 1, 2, 3, 4, 5 times y. And then I'm going to do it again with the middle group, that pinkish purple group. 1, 2, 3, 4, 5. And then one more time. 3, 4, 5 times y. So what's going on here? So how many 3's do I have? I have 3 groups, each with 5 in there. So that's 15 3's, or 3 to the 15th. And how many y's do I have? 3 groups again, but each one has 2 y's in there. So that would be 6 y's. So 3 to the 15th, y to the 6th. All right, so now we've got to come up with the rule, because I'm sure you're not going to do this repeated multiplication every time. So if you'll pay attention to your exponents here and your exponents in your final answers, you should be noticing a pattern here. So what is that pattern that you might notice? What are we doing with the exponents? All we're doing, you'll notice, is multiplying the exponents. So you're going to keep the base and you're going to multiply the exponents. That's all you're going to do. And I really want to point out this one right here. So for this one, that 3 to the 5th cubed, you were multiplying the 5 and the 3 to get that 3 to the 15th over here. And then when you had the y squared cubed, you were multiplying the 2 and the 3 together to get the y to the 6th over here. So you did it to each individual piece. So how do I write this rule algebraically? So again, I'm going to start off with that x to the m power. So you have some exponential expression. And then it's in parentheses, and outside of the parentheses, you have a different exponent to the n power, we'll say. So what are you supposed to do? We said multiply the exponents. So mn, which is what I've written here, means that you're multiplying those exponents. So this is your main rule. Okay. Let's do a couple more examples just to make sure we understand. So let's suppose I had 7 to the 8th to the 4th power. So what am I supposed to do with those exponents? Well, I keep my base, and the exponents I'm supposed to multiply them. So I'm going to do whatever 8 times 4 is. Well, 8 times 4 is 32. So that would be 7 to the 32nd power, which I'm sure you didn't want to have to expand that out to figure it out. What if I had 4, let me put an exponent here first. 4 to the negative 1 power squared. Well, I keep my base of 4. I multiply my exponents, so I'm going to do negative 1 times 2. Well, negative 1 times 2 is negative 2. And so I end up with 4 to the negative 2 power. Remember, my negative exponent rule says that this is the same as 1 over 4 squared. And you could even say, well, 4 squared is 16. So on a test, you could see the answer written like that, 1 over 4 squared, or 1 over 16, because that one is a simple one for you to figure out. I want to do one more where you have a negative base. So let's suppose I have negative 2 as my base, and it's squared and then cubed. Okay, well, I'm going to keep my base of negative 2. And again, I'm going to multiply those exponents. 2 times 3. So 2 times 3 is 6. So that's negative 2 to the 6th power. If you don't have that -2 in parentheses here, then it would not be wrong, or it would be wrong. So if you wrote this, wrong, because the base was in parentheses and it needed to stay in parentheses. So this would be the solution here. Okay, so again, once you're finished with this sheet, please make sure you've got all this information copied down. Once you're finished and you've submitted it, you'll be ready to do your independent practice. When you're completing your independent practice, take your time. You can come back and look at this video if you need to. But once you're finished with the independent practice, look at the answer key that is provided and check your answers in a different color. Give yourself a check if it's right and X if it's wrong. If it is wrong, do not erase the wrong answer. To the side, write down what the correct answer should be. And then look and see if you can understand why you missed it. If you can't, then you need to speak with your teacher and see if you can come to an understanding about why you got it wrong. But actually try to see if you can figure out why you've made that mistake, because that's when learning happens, when you're learning from your mistakes. Okay, good luck.